Okay, guys, when you factored the first one, what did you get once you factored? Danny? Good, the quantity of x plus 2 squared. What about number 2? What did you get when you factored? Kai? Good, the quantity of x minus 4 squared. Right. So this is no coincidence. These original trinomials were called perfect square trinomials. So all perfect square trinomials look like one of two scenarios. The first one is a squared plus 2ab plus b squared. And that factors into a plus b squared. And I'll show you. So we know when we have a quadratic, it's ax squared plus bx plus c. So the first coefficient in a is the first coefficient goes with our a squared. The last goes with our constant. So right now, our a squared right here is 1x squared. Well, if a squared is 1x squared, what is just a? If a squared equals just x squared, what is a? A is just x. And then our constant is our b squared. So if b squared is equal to 4, what is b? 2. So now we check this to see if it's a perfect square trinomial. We have our a is x, our b is 2. Does it fit this a squared plus 2ab plus b squared? So a squared would be x squared, b squared would be 4. So far we're good. Now we check the middle. Is it 2ab? Well, 2 times a times 2. Well, 2 times x times 2 is a 4x. So is this a squared plus 2ab plus b squared? Yes, so we can quick factor that into a plus b squared. The other perfect square trinomial fits the format of a squared minus 2ab plus b squared. And that factors into the quantity of a minus b squared. Okay, so here we're checking this trinomial to see if it fits the format. Well, if a squared is x squared and b squared is 16, do we agree a is x, b is 4? So now we check the middle term. Is it 2 times x times 4? Yes. So this is definitely a perfect square trinomial, but because of the minus in the middle, it factors into a, the quantity of a minus b squared. Okay. Now what I want us to do is solve each equation square root method. Now, when you're solving square root method, what you want to do is you want to get whatever quantity is squared, you want to get it completely by itself. Right? Which quantity is being squared here? Just the y. So if possible, I want to get y completely by itself. Can I get y by itself? Yes. On the flip side, if it's just multiplication between them, you can leave that multiplication. It's not going to make a huge difference in your life. So if you didn't want to divide the 3, you could have left the 3 there and still solved square root method, but it would have just taken you a more complicated route. Okay, so here, because we can easily divide that 3, we're going to choose 2, since it's really just the y that's squared. We're going to divide by 3 on both sides. Then we're going to have y squared is equal to 25. To undo a square, we take the square root. But the minute we take the square root when we're solving, what do we have to put in front?
Plus minus.
Yep. Y equals plus minus 5. Okay, once again, our goal, if possible, is to get whatever quantity is squared, we want to get it by itself. Whatever quantity is squared, we want to get it by itself. So this time we want to get the x squared by itself. How are we going to get the x squared by itself? Subtract the 5. And that's going to bring us down to x squared equals 10. To undo a square, we will take the square root. Do not forget, the minute you take a square root, it becomes plus or minus. Can I simplify the root of 10? Any pairs there? No, so we leave it just like this. Got it? Okay, we're solving for n. There's two n's. We need to get them both on the same side. So what I'm going to do is I'm going to subtract 4n squared on both sides. That's going to bring us down to 16n squared equals 81. Just the n is being squared, so I'm going to divide by 16 on both sides. So now I have n squared equals 81 over 16. To undo a square, we will take the square root. The minute we take a square root when we're solving, what do we have to put in front? Plus or minus. Now, what's nice about 81 and 16? They are both perfect squares. So this is the same as saying root of 81 over the root of 16. So n will equal plus minus 9 over 4. So here we have 2 times the quantity of x plus 2 squared equals 40. You want to get whatever quantity is being squared by itself. This time the quantity that's being squared is x plus 2. So I need to get the parentheses basically by itself. So to do that, I can divide by 2 on both sides. So now I have the quantity of x plus 2 squared equals 20. To undo a square, we are going to take the square root. So now the square root and the square cancel, so now we have the quantity of x plus 2 is equal to plus or minus the root of 20. Can we simplify the root of 20? Yeah. What is that? You got it. So x plus 2 equals plus or minus 2 root 5. We're not done because we're solving for x. So now to solve for x, do we all agree I must subtract the 2? So now this is going to be x is equal to negative 2 plus or minus 2 root 5. And because I cannot subtract or add 2 and 2 root 5, we leave it just like that. Okay, so now we're going to talk about how do we solve by using completing the square. You've learned this in Algebra 1, but you probably forgot. All right, the steps to solve by completing the square, we want to get all terms with a variable on one side and any constant on the other side. So let's say we have, I'll put a problem next to it. X squared plus 6x minus 7 equals 0. I know we can factor this without completing the square. It is a lot easier to factor this without completing the square. But I need you to learn the process on a simpler problem, so then when we go to the more difficult problems, it's easier. So this is really not about, oh, we don't need to complete the square to solve this. I understand that. I'm just using an easier problem to teach you how to do the process. All right, so it says get all the terms with variables on one side, anything that doesn't have a variable on the other. So I'm going to keep x squared plus 6x on one side, and I'm going to move that negative 7 to the other side by adding 7 on both sides. Okay, next step. What we're going to do now is take half of the x coefficient then square it. And we will add that product to both sides. Okay, so I'm going to go to the x coefficient, which is 6. And what did I say to do? I said take half of 6. What's half of 6? 3. And then what did I say to do? Square it. 3 squared is 9. You're going to add that 9 to both sides, to the left side and to the right side, to keep our equation balanced. Okay, next step. We're going to factor the trinomial, and it should absolutely factor into some quantity squared. It's like a plus or minus b squared. So x squared plus 6x plus 9, this is absolutely a perfect square trinomial. Our a is x, our b is 3, our middle term is 2 times 3 times x, which is 6x. So is this a perfect square trinomial? Absolutely. How does a perfect square trinomial factor? Well, this one, because it's a plus, it's going to be a plus b squared, so x plus 3 quantity squared equals 16. Your last step to solve is going to be solve square root method. So go back. We have the quantity of x plus 3 squared equals 16. To undo a square, we take the square root. The square root and the square cancel, so then we get x plus 3 is equal to plus or minus 4. Now to solve for x, we need to subtract the 3 on both sides. But what ends up happening is we end up getting two different equations. We end up getting x is equal to 4 minus 3, but then don't we also end up getting x is equal to negative 4 minus 3? So we end up with x is equal to 1 and also x is equal to negative 7. Why does it make sense that we have two answers? Philip? From the beginning, why does it make sense that we have two answers?
I mean, whenever we like factor trinomial easily, you get two answers from both like.
Yeah, how do you know it should be two answers and not like 3 or 4 answers? What tells us that?
It's like a quadratic equation.
Which means it has to have a degree of? X squared, exactly. So the highest degree of the polynomial tells you how many solutions you should get. So because the degree of here, the highest degree is 2, that means we're going to get 2 solutions. Doesn't always mean that all our solutions are real numbers. Sometimes they end up being imaginary numbers, but it will tell you how many solutions you have. The highest degree, the highest exponent on the polynomial tells you how many solutions you should have. All right, let's do a little bit more with this. Okay, you guys try this one on your own, and then we will step it up a bit. So I want you to solve by completing the square. I know you don't have to. I know you could factor this normal and solve, but I want you to practice completing the square. So remember, I know that you can factor this without completing the square, but I want you to complete the square. So the first step in completing the square is x squared plus 4x. We're going to move that 96 over. Then we're going to take half the x term. Half of 4 is 2. 2 squared is 4. So we add 4 to the left side. We add 4 to the right side. Then we go ahead and we factor the left side, which will become x plus 2, that quantity squared, equals 100. Our next step is to solve, so we solve square root method. So we get x plus 2 is equal to plus or minus 10. So then we end up with two different equations. X plus 2 equals positive 10 and x plus 2 equals negative 10. Which gives us x equals 8 and x equals negative 12. How many people did the whole process correct? Good. All right, let's step it up a little bit now. Okay, so again, we want to solve by completing the square. We want everything with a variable on one side, anything that doesn't have a variable onto the other side. So I'm going to move the 5x over. Now our rule says, our steps tell us to take half of the x coefficient. Well, my x coefficient is 5, so to take half of that would be a decimal. I would actually choose to leave it as an improper fraction. So what do I mean when I say I would choose to leave it as an improper fraction? I would say, okay, well, we're taking 5, dividing it by 2, so I'll leave it as 5 over 2. And then after you take half the x term, what do? We square it. So if I'm going to take 5 over 2 and square it, don't I end up with 25 over 4? So now what I'm going to add 25 over 4 to the left side and to the right side. So our left side ends up becoming a perfect square trinomial. So remember, this is a squared minus 2ab plus b squared. So this will end up as a minus b quantity squared. So my a is x. If my b squared is 25 over 4, what's b?
5 over 2.
5 over 2, you got it. And now on this other side, we need to create a common denominator. So I'm going to create a common denominator of 4. So it's negative 8 over 4 plus 25 over 4, which is going to give us 17 over 4. Now we solve, so to undo a square, we take the square root. Do not forget your plus or minus. So x minus 5/2 is equal to plus or minus root 17 over root 4. This is actually nice because our denominator is a perfect square, so we don't have to rationalize. So we end up with x minus 5/2 is equal to plus or minus root 17 over 2. Now to solve for x, all we're going to do is add the 5/2 on both sides. So what we end up getting is x is equal to 5/2 plus or minus root 17 over 2. At this point, if they didn't have a common denominator, you would create one. But because they do have a common denominator, you just write it like this: 5 plus or minus root 17 all over 2. And those are two solutions. 5 plus root 17 over 2 is one solution, and 5 minus root 17 over 2 is another solution. Okay, next one. Okay, so I'm going to rearrange this a little bit. X squared plus 6 root 5x plus 40 equal, well, actually, minus 40, right? Because we're moving the 40 to the other side, move the constant to the other side. Now, if we're solving by completing the square, I say go to your x coefficient. What's the x coefficient in this scenario? 6 root 5. And what did I say to do? Take half of it, right? So 6 root 5 over 2, isn't that 3 root 5? Then what did I say to do to that 3 root 5? Or that half, that quotient after we divide by 2? Square it. You got it. We take half of it and then we square it, which is now going to give us 9 times what? 5, which is 45. So I'm going to add 45 to our left, and I'm going to add 45 to the right. Guys, when we come to factor this side, we already know it's a perfect square trinomial, right? Because we made it a perfect square trinomial. So when we have our A and our B, well, what did we get? How did we get 45? Didn't we square 3 root 5? So what is this 40, what is our, if our B squared is 45, our B has to be 3 root 5. Does everybody see how I made that connection? Because that's a time saver right there. All right, so now this is going to be the quantity of A plus B squared. So this is A plus 3 root 5 squared equals 5. Now to undo a square, we take the square root. So now we're going to have A plus 3 root 5 equals plus or minus root 5. So now we're going to have A plus 3 root 5 equals positive root 5. And we'll also have A plus 3 root 5 equals negative root 5. When we subtract that 3 root 5, because they're like terms, we're going to end up with A equals negative 2 root 5 as one solution. And on the other side, when we subtract that 3 root 5, we're going to get A is equal to negative 4 root 5 as our second solution. You don't see how I made the 3 root 5 connection? So do you understand that this is going to be A plus B quantity squared? Because we completed the square, so we made it into this. So now we know our A is X, right? So now our B is going to be the square root of 45. So you could look at it that way and just take the square root of 45 and simplify it down. Or you could know, how did we even get 45? Because it wasn't part of the original thing. We squared 3 root 5. So if we had to square 3 root 5 to get 45, then that means the square root of 45 would have to be 3 root 5. Does that make sense? Are you just saying it? Because you nodded your head last time when I said, does everybody see the connection?
No, but
Now this time you get it? Okay. All right, I have a few more problems, I think. Yes. Okay, what do we do when the leading coefficient is not 1? So when the leading coefficient does not equal 1, what I want you to do is divide it out. So I'd still move that 7 over, so 3x squared plus 4x equals positive 7. But we do not want to complete the square when there's a leading coefficient. So in this scenario, when we're solving, I'm going to ask you to divide it out. So what would I have to divide or multiply, depending on what it is? What would I have to divide 3x squared by for it to be 1x squared? Wouldn't we divide by, Philip? 3, yeah. So we're going to divide by 3 under everything. So then we're going to just have x squared plus 4/3 x equals 7/3. And now we complete the square. I'll let you all catch up. So for some reason, a lot of people will have problems working with the fractions. All right, now when we're completing the square, what is our next step? We've moved the constant to the other side. We've made sure our leading coefficient is 1. What do we do now? What's the next step? Take half of what? the coefficient of x. Okay, guys, you know how to do simple fractions. We do. We know operations with fractions. So what did I say? I said take half of the coefficient on x. Well, do we agree the coefficient on x is 4/3? So to take half of it is dividing by 2 or multiplying by a half. Yeah. So 4/3 times a half. What's 4/3 times a half? 4/6. So you can simplify 4/6, but it might complicate things if you when you come to factoring. It might complicate things when it comes to factoring. Let's see what happens when you simplify this. So this would go down to 2/3, right? And then we're going to take that 2/3 and we're going to square it. What's 2/3 squared? 4/9. Yeah, 4/9. So we're going to say plus 4/9 to the left side and plus 4/9 on the right side. Actually, it's still working out the same. It's not that bad. All right, so here we're going to have x plus. Right, do we agree this is going to be a quantity squared? Right, some quantity squared. So our a is x, our b squared is 4/9, which means if my b squared is 4/9, what is my b? 2/3. And now this is going to equal 7/3 plus 4/9. What must I do now?
Common denominator.
A common denominator, you got it. So now we're going to have the quantity of x plus 2/3 quantity squared equals 21/9 plus 4/9 equals 25/9. Now we square root both sides. So x plus 2/3 equals plus or minus 5/3. Am I going too fast for you? We're okay? Yeah? Okay. So now we're going to have x plus 2/3 equals 5/3. But we're also going to have x plus 2/3 equals negative 5/3. So when we subtract in the first one, we're going to get x is equal to 3/3, which is 1. And in the second one, we're going to have x is equal to negative 7/3. Okay, if I can get through 2 more problems, I'll be happy. 2 more, yes. When we're completing the square, what do we need the leading coefficient to be? 1. This is 1/8. Hey, I don't want 1/8. I want 1. So what should I do to make that 1/8 1? Your options are only multiplication or division. There's no adding here. Your options are only through multiplication or division. Philip? You can multiply by 8. Now, if I multiply one thing by 8, don't I have to multiply everything by 8? Yeah. So now we're going to get n squared minus 8n equals 4. Yep, not so intimidating anymore, huh? Now we complete the square. Half of 8 is 4. 4 squared is, so I add 16 to the left and I add 16 to the right. We factor the left, which will be n minus 4 quantity squared equals 20. We're now going to square root both sides. We are going to get n minus 4 equals plus or minus 2 root 5. And actually, when you end up with a radical, it's not so bad because then you don't have to make two different equations, right? We could just add that 4 over and have n is equal to 4 plus or minus 2 root 5. All right, last problem for us. How about you guys try this one on your own? Try this one on your own. All right, who has an answer for me? Tejas?
6 plus or minus 2 root 6
Over 3?
Yeah.
You got it. How many people got that?
Wait, what is that?
6 plus or, oh, not 2. I wrote 3, sorry. 2 root 6, sorry. He said it. I just wrote it wrong. 6 plus or minus 2 root 6 over 3. How many people got that? Uh-oh. Do we need to do this over? Do we need to do it? Clearly? Okay. Let's do this. Oh, did you guys get? Oh. 2 plus or minus 2 root 6 over 3. Did you guys get that? Okay, you want to make a common denominator so you can put them together. How many people got this? Oh, Tejas, is that what you had originally said?
Said 6 plus or minus 2 root 6 over 3.
Oh, you said, oh, this is 6 plus or minus 2 root 6 over 3. So what I had originally said. No?
Yeah.
All over 3. Okay, how many people need to see me do this? All right, let's do it. So you wanted to create a common denominator there so you can put them together. So right now we are dividing out the 3. And we're going to get z squared minus 4z. I'm going to move that 4/3 to the other side equals negative 4/3. I think everybody was pretty good with that. What's wrong? Did I write it wrong? Why do you look confused? Philip, you okay?
I'm just trying to figure out the answer that we were talking about before. I'm just trying to figure out how to like.
I'm going there. I'm going there.
Sorry.
Okay. So now we are going to do half of 4 is 2. 2 squared is 4. Add 4 to the left, add 4 to the right. So now we're going to have z minus 2 squared equals, I'm going to create a common denominator here, negative 4/3 plus 12/3. So we're going to have z minus 2 squared equals 8/3. To undo a square, we take the square root. So here, this is where we saw something a little bit different. We have the root of 8 over the root of 3. Every other time we've seen this today, hasn't it been a perfect square in the denominator? It's not a perfect square, so what do we have to do? Rationalize it. So now we're going to get z minus 2 equals the root of 24 over 3. But can I simplify the root of 24? Absolutely. So we're going to get z minus 2, plus or minus. Z minus 2 equals plus or minus 2 root 6 over 3. Then we add the 2 over. So z equals 2 plus or minus 2 root 6 over 3. This is where I think the majority of people said they got their answer, right? Yes? So then I said create a common denominator. How do we create a common denominator? We're going to make this 6 over 3 plus or minus 2 root 6 over 3, which is going to give us 6 plus or minus 2 root 6 over 3. Yes? Good? How many people feel confident about